Good day, folks. This is tutorial number 8 in a playlist that's called Transition from Catia V5 to 3D Experience Release 2025x. Now, the tutorial will discuss what is called Euler angle option when you try to create an access system in the partisan application. Now, remember, the version of Catia that's buried inside of 3D Experience, we refer to it as 3D Experience Catia, and it's not quite the same as the Catia V5 interface. Some of the icons look the same, the organization is completely different. I've also produced specifically this particular topic for the Catia V5 application, which is appearing in a different playlist, not the 3D Experience one. So the situation is this: when you have a part, you have the global, of course, coordinate system X, Y, Z, but you can create your own access system by clicking in the access system icon here. This dialog box opens up. Now, notice that there is a pull-down menu. Which allows us to select different ways of creating this access system: standard, axis rotation, and Euler angles. This specific tutorial is concentrating on Euler angle because the other two are fairly straightforward as far as understanding is going. So this is what I'm interested in. Now, Euler angle is something that is used for determining the orientation of rigid bodies, or it's called attitude. Now, I'm not teaching you how what Euler's angles are in a sense, but there's 12 sequence of them. The specific one that is implemented in Catia / 3D Experience Catia is the 313 sequence, or ZXZ sequence. So when you click on that icon, automatically a global coordinate system is created for you, which is aligned with the global coordinate system. Here is denoted with X, Y, Z. Now, so here's the situation. You clicked on that icon, you selected the Euler angle, this is what you get. Now, suppose I put a 90, I use 90 and minus 90 because then you can see things on the screen. So suppose for angle 1, I put 90. What does that mean? It means go to your coordinate system that was created for you, rotate about the Z axis, this first number, remember, Z, X, Z sequence, or 3, 1, 3 sequence. So when you put a 90 here, means go to this axis system that was created by default, rotate about the Z axis by 90 degrees. Notice that when you rotate about the Z axis by 90, positive 90, this X will end up in the place of Y, and Y will end up on the other side along the X direction, forward X direction. So when you put a 90 in the first box, this is what you get. If you put a 90 in the second box, remember Z, X, Z. If you put a 90 in the second box, it goes to the new x-axis and rotate it by 90 degrees. Here, I put a 90 for the second angle. It goes to the new x-axis, which is right here, and rotate it by plus 90 degrees. So notice that what happens, Z is going to be lined up with the former Y, and Y is going to go up and replaces basically the Z axis. So 90, 90, 0. Z, X, Z. If you put a 90 in the last angle, it goes to, again, remember, Z, X, Z. It goes to the new Z axis, which is right here, and rotate it by plus 90 degrees. So X is going to go up, Y is going to go to the left, lined up with the old X, and of course, Z is going to stay put. I'll do another example, and then I'll demonstrate for you on the screen. Okay, here's another one. Let's click on the z-axis, click on the axis system again. By default, it creates a global an axis system aligned with the global directions. Now, if you put a negative 90 here, it goes to the z-axis. Remember, z, x, z. It goes to the z-axis and rotates it by minus 90 degrees. When you rotate this thing by minus 90, this x here is going to line up with the old y, but on the left side of it, and y is going to come and replaces x-axis. Now, if you put another 90 here, which means z, x, z, it goes to the new x-axis, this was the new x-axis, and rotates it about that by positive 90 degrees. So z is going to go down here, and of course y, which was there, by rotated by 90 degrees, is going to end up with the previous location of z. And finally, if you put another minus 90 in z, x, z, so it goes to the new z-axis, this was the new z-axis, and rotates about it by minus 90 degrees. So x is going to go down and y is going to go pointing to the left. So that's what it is. So I've done two examples for you. I'll do another one. Let's click on the axis system again. This is what we get. If you put a 90, of course, you know what's going to happen. It goes to the z-axis, rotates it by plus 90 degrees, so we can see what happens. Y is going to go there, and x is going to go here. And if you don't put anything for the angle 2, it just keeps it the way it is. And finally, if you put a minus 90 for the third angle, remember z, x, z. It goes to the new z-axis, which is this one, and rotates it by minus 90 degrees. So if you rotate this thing by minus 90 degrees, y is going to go back to where it was originally, and x is going to go back to where it was originally. Now, I could have done this thing for other angles, but then you will not be able to see what's happening on the screen. Now, here's the, the the documentation, the help manual. It's not very helpful. So what does this mean? Look at what it means. So ZXZ. So what this diagram means is that the first angle, you rotate about the z-axis. When you rotate about the z-axis, this x is going to move to that new location. Okay? So this one means that your first rotation is about the z-axis. So this x-axis in the old plane xy is going to move to this new location. When you put in the next angle, angle number 2, that is the x-axis. So it takes this the new x-axis and rotates about that by that angle. So what happens is that this z is going to go to a new location, w. And finally, when you put the last number in there, it goes to the new z-axis. This is going to be the new z-axis, and rotates it by the third angle, which means that uh, uh, this n is going to go end up with some other location. This is not very helpful, but the example that I showed you cleans it up. So let's go ahead and actually see what's going on. I'm going to do the first angle for you, which means what I mean is I'm going to do this example for you. Remember, I did 90 for the first angle, then 90 for the second angle, and finally 90 for the third angle. So let's go ahead and do that. So click on the axis system. Okay. Change to Euler angle. First one, I put a 90. This is rotating about the default coordinate system, which is lined up with the global one. Rotates it about the z-axis by 90 degrees. So notice what happens. This x is going to go here, y is going to go in the back. So this x is going to go here, y is going to go in the back. Now, if you put a 90 there, it goes to the new x-axis. This is the new x-axis. Rotates it by 90 degrees. So z is going to line up here. It's coming towards you. And y is going to go up. Y is going to go up, z is coming toward you. And finally, if you put another 90 here, it goes to the new z-axis and rotate it by plus 90 degrees. So x is going to go up, y is going to go to the left. There we are. So that's what these things are that I showed you. And you can practice if you want by yourself. Hopefully that clarifies something. It always bothered me, but the documentation is not very helpful. That diagram is very confusing, and they don't actually state exactly what they're doing. So it's the specific uh, Euler sequence that is being implemented in Catia slash 3D experience Catia is actually ZXZ sequence or 313 sequence. Good luck.